The coordinate geometry of the line formula are found on page 18 of the Formula and Tables book. Find the coordinates of A and the coordinates of B. Point A has the x value of -2 and the y value of 3. So A is the point -2, 3. B has an x value of 6 and a y value of -1. So B is the point 6, -1. The y-intercept of the line AB. The y-intercept is where the line cuts the y-axis. Here we see it cuts the y-axis at the point 2. So the coordinates of the y-intercept is 0, 2, because the x value here is 0, but the y value is 2. Next, we're asked to find the midpoint of the line AB. One way of finding the midpoint is just by looking at the diagram. We could see halfway between B and C. That's what the midpoint is. It appears to be this point here, 2, 1. Just a way of checking this, one way is we could kind of construct a rectangle that looks like this. What we know is that the diagonals of a rectangle intersect. Because of symmetry, this rectangle that has opposite vertices of B and C, if we construct the diagonals of this, so one of the diagonals is the line segment AB, but the other diagonal, which comes through this way, and we can see that, yeah, this seems to confirm midpoint of the line AB happens where the x value is 2 and the y value is 1. So it's at the point 2, 1. A is the point -2, 3. And B is the point 6, -1. By the midpoint, we mean the average point. So if we add these together and half them, we get the midpoint or average point. So 6 take 2 is 4. And 3 take 1 is 2. And if we half this, it would be the midpoint. So the midpoint of the line AB would be half of 4, which is 2, and half of 2, which is 1. So it's the point 2, 1. There is a formula for this called the distance formula, given the log tables, but we could also just use Pythagoras' theorem to find this. So if we construct this triangle that contains A and B as the vertices, this is a right angle triangle, we would consider then the lengths of this triangle. So we see that going from this side and the left hand side, it seems to be 1, 2, 3, 4 units. So this is a distance of 4. Going along this way, it's from -2 to 6, which is a distance of 8. And according to Pythagoras' theorem, the square on these two sides, so I square 4 and I get 16, and square 8, I get 64, sum to the square on the hypotenuse side. So on the hypotenuse, so the answer to the question is the square root of 80. Now, if you put this into the calculator, we'll see that the square root of 80 is equal to 4 root 5. So we could probably leave it in whatever way the calculator tells us. So 4 root 5 or the square root of 80. Let me look at how to do this using the formula either. The formula says that the distance d is equal to the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So we carefully sub these numbers into the formula. The distance AB then becomes the square root. Instead of x2, I put 6 minus x1 will be minus -2, which is plus 2 to be squared. And what that means is what I'm really doing here is the distance between -2 and 6. That jump is a jump of 8. That's why 6 plus 2 is 8. And to that I add y2, which is -1, take away y2, which is -3. That gives us -4 squared. And what we're saying here in the picture is you go from 3 to -1. The jump there is a jump of -4. That's what's going on there. So the answer to this question would be 8 squared plus -4 squared, or plus 4 squared if you want. We're going to get a positive answer when we square it. Again, just like before, if you put this into the calculator, it'll say the square root of 80, or it'll say 4 root 5. That's using the distance formula. The next question here is to find the slope of AB. So the slope is to do with how it's changing. So we can see that it kind of steps along to these kind of nice points. It seems to move like this. I go down 1, across 2, down 1, across 2, down 1, across 2. So the slope is the rise over the run. It seems to be when we go down 1, that's a -1 change, and across 2, that's +2. M is the letter for slope, is the rise over the run. So in this question, we see it's the rise is -1 and the run is 2. So -1 over 2, or -1/2, is the slope. Next question is find the equation of AB. Again, there are maybe two options here when you think of finding the equation. So one formula that I could use is y equals mx plus c. And the other option I have is y minus y1 is m times x minus x1. In this example, however, we seem to know both m, that we've just worked out, -1/2, and c, the y-intercept. So this is the point c, the y-intercept point in this question is equal to 2. And we've just worked out here that the slope of this is -1/2. So if you know the slope m and c, the y-intercept, well, then we could just sub those values into y equals mx plus c and have our solution. So y is equal to, instead of mx, it's -1/2 times x plus c, which is +2. And there's the answer to the equation of the line. The last question is find the equation of a line perpendicular to AB containing A. Okay, let's imagine what this looks like. So a perpendicular line to AB. So this is line AB. The way this seems to be moving is we go down 1 and across 2, moving this way. A perpendicular line would be moving something like this. And instead of going down 1 and across 2, it would go down 2 and across 1. Okay, so it would look something like this. But this line contains the point A. So it's a line that goes through here. Just draw a little sketch of it here. So this line here, I want to know the equation of that line. Okay, to find the equation of the line, I need two bits of information. One is a point. We have a point. The point that we have here is we know that point A here, which it contains, is -2, 3. So I know that. That's something I'm going to use. The other thing I need to know is about its slope. Well, the slope of the line that's given here, this one we already have. This one here, line AB, has a slope equal to -1 over 2. And a slope that's perpendicular to that is the negative reciprocal. What we do is we flip the fraction and change the sign. It becomes +2 over 1, or just +2. So that's a slope of 2. We can see that from the picture, how that's true. Look, every time I go out 1, I go up 2. So the rise over run is 2 over 1, or 2. And now I have the information I need to find this equation of this blue line that's perpendicular to AB, because I have a point and I have the slope. So find the equation of the line. This time I'm going to use the other formula. So the equation of the line formula is y minus y1 is equal to m times x minus x1. Okay, so into this formula, I know that the slope of this perpendicular line is 2, and it contains this point A. So I put these into the formula. So it becomes y minus 1, which is minus 3, is equal to m, which is 2, into x minus x1, which is minus negative 2, which becomes plus 2. This is the answer. We might tidy it up a bit, maybe multiply out the brackets. Y minus 3 is equal to 2x plus 4. Now, often we like this equation left in what we call standard form, with the x part, the y part, the number part equals 0. So one way of doing that would be if I subtract y from both sides and I add 3 to both sides. When I do that, I would imagine that on the left hand side I'm left with 0. So 0 is equal to 2x minus y plus 4 plus 3. So 2x minus y, 4 plus 3 is 7. We said all that equals to 0. And there is the equation of the line perpendicular to AB that goes through the point A.